Yes, we are going to override. So let's go to the grids and beam grid. Let us make 5 meter, another 5 meter spans, and let's go to the properties. Here we can make the section database. Let's make one W beam, W4 by, I didn't add it, and then we can assign this beam to the view. Once we assign this one, let's go to the supports. Let's create 2 pinned supports. Add. So here this node, as well as here this node also we will create it. So we have assigned these 2 nodes. Okay. Now we will apply the UDL, and then we will see this effect of the reaction at 2 points. So instead of this node as 5 meter, here we have kept this node as 5 meter. That nodes we can change to this 5 meter span, 5 meter span, that we will change. Here instead of 5 meter span, we will keep it. This is only 2.5. So that means 7.5 it will come. So let us see how this is 5 meter and this is 7.5 meter. We will apply load here and here. We will see the effect of load and reaction. Here we will apply the uniformly distributed load, loading portion. We will add one new load case. And then we will add load. So here in this one we are going to add a load case of UDL on the member. So we will put member. We will take this AB 5 meter is there, right? That 5 meter we will apply here in the W1, right? It is showing W1 kilonewton Y direction minus. We will put it 1 kilonewton per meter itself. We will add this load to here, and then here at least we will apply equivalent, means half. If you apply these 2 loads will be equal. So we will apply little more, 3 meter we will apply. Okay, so we will add one more load also, member load, uniform distributor load, and from starting from here D1 we will keep it this 5 meter, right? So we will keep it 2 meter. This also minus 1, and load length is full length it will come. So we will add it. So this we will apply it for this member. So here what we are doing it, this is 5 meter span. Out of that 5 meter, 3 meter span we applied 1 kilonewton, another 2.5 meter we applied in uniform distributed load. Now we will see like here the reaction should be upward. Then it will have the sagging bending moment here. Then this will be the like this it will come. Okay. So let's go to the analysis and perform analysis, and we will run the analysis. Run the analysis. So once we run analysis, we'll go to post processing. We will see the deflection pattern here. We can see deflection here, hogging, and here sagging is there. And the reactions also you will see it. Reactions you can see Y is 0.25 because we have seen 3 meter plus 2.5. 3 plus 2.5 is 5.5, right? 3 meter we applied load plus another 2.5, so total 5.5. That's a kilonewton. So reaction if you see 5.225 at this corner, at this joint. So remaining is 0.25. So this reaction is upwards only. This is positive. That's why if you see bending moment, we can see there is a sagging bending moment and hogging bending moment. Suppose if this load is we are changing it to equal. Instead of 3 meter it starts, right? It starts with that 2 meter, right? So what we can make it, if it is starting with 2.5, that means equal load. Here the equal, here also equal load. What will happen, we will see, and we will reduce this to only 1 meter. Then we will see how the reaction, how it looks like. Okay, so for that we need to go to this once again, analytical modeling. Then loading we have to go. Then this loading we will see here in load case. So this load case, this is okay, and this load case only we have to change. Instead of it starting with the 2, we will start with the 2.5. That means equal load. This also 2.5, this also 2.5. Let us see now the reaction. Modify it, then close, and we will do the analysis once again. Run analysis. Once we run the analysis, we will see here how the reactions are there. Here you see this seems single curvature. There is no sagging moment, right? So beam results, if you see here, this moment becomes 0 here. So this is Hogging moment. Values also, if you see it here, the value of the moment is 2.5 should come, right? So it's like a uniformly distributed load. So distance equivalent distance is here. Then bending moment is 27.659 is the maximum, because here it's uniformly distributed load. So this is 2.5 into 1 into 2.5 kilonewton into 2.5 divided by 2, right? So it becomes this moment we need to calculate, right? The bending moment. Bending moment, how we can calculate? This is the uniform distributed load. Load into distance, right? Load is how much loading, 1 kilonewton per meter, and distance is, what is the distance of this member? 2.5 meter. So 2.5 into 2. 2.5 into 1 is the total load is 2.5. That is acting at 2.5 divided by 2, right? 2.5 into 2.5 meter divided by 2. So it's a 3.125. All right. So here the moment is in unit is kips per inch. That's why this value is equivalent to 3.125. Units, we can change it, then it will become different value. So this unit is 27.6659, means that is equal to 3.125 only. The same amount only this side also it will be there, and 0 it comes at this point itself, because we have applied equal amount of load. So there is only one high amount. Suppose if we reduce this one, what will happen? We can see that time also it will become, the curvature will become single curvature instead of double curvature. The previous one it was double curvature, now it's single curvature. Let's go to the analytical model once again. Loading, if we go here and if we change that load, instead of equal load, instead of starting at 2.5, we will make it 4 meter. That means we are changing it. Cantilever reaction, we have increased it. Now before that we want to see the reaction, right? Reaction we didn't see how much reaction is coming, right? The previous run itself reaction we didn't see. So reaction also we will see it. So this is equivalent to 1. So reaction, if you see it here, it becomes 0. Entire load is acting at here only, right? Here it becomes 0, you see, and the entire load here 2.5 total 5 kilometer is concentrated here only. So now we will see these changes. If we change to, instead of a 2.5 equivalent value, you are making it 4 meter. That means 1 meter only it's going to act. That means the reaction it should come. Now it's in negative reaction. Instead of upward reaction, downward reaction should come. We will see how it comes. So here it is completely single curvature, and reaction, you see this is minus 0.525 and here plus 5 to 5. Moments also, if you see, this is completely until this start of the UDL, it becomes straight line. After the start of the UDL, it becomes parabolic. Then this parabolic, it comes. This is how we can see the effect of loading. So qualitative analysis. Earlier, it was when you want to